to a SaltyChillersEntertainment podcast. This is Hero Darkness.
Salt Logic.
Which numbers?
Valentine.
In today's episode, we're talking about wormholes and black holes, and is there a possibility that we can travel through them, or are they, in actuality, as small as science say they are?
Probably just as lethal.
And it's even possible in this current state for us, if they are real, to be able to travel in. So to start off, does any of us know about the wormholes? Oh, go ahead, Salt.
Okay, well, no, I was gonna be sure that we need to, kind of explain what a wormhole and a black hole is.
That's actually a pretty good point.
And I have an idea what a wormhole is. At least a definition, anyway. A wormhole is made by a burrowing insect larva or worm. Wait, nope. Ha! Wrong definition. Wormhole!
Well, I mean, that is a wormhole, a hole that a worm makes. So, yes, that is a wormhole.
Wow.
Anyway, the correct
how would that work
in
in space now, Salt? Explain.
A giant space worm nods through space, and it's a wormhole.
Anyway, wrong definition. A hypothetical connection between widely separated regions of space-time. That is the definition I wanted to say.
Alright, Rich, you were gonna go and explain the wormhole.
Well, yeah, what Salt mentioned is a very basic definition of wormhole. It's basically it's a point between 2 points in space that you can travel through, like a hole. So in general, when I'm thinking about wormholes, you can take a piece of paper and you can then punch a hole in it, unfold the paper, and the two holes are at, that's the distance you'll be traveling. There's a wormhole. Now, a black hole is something also quite interesting. A black hole is after a star burns, goes supernova, and expands out. There's a chance of it then the gravity from the star collapses in on itself. And by doing so, it creates the black hole due to the gravity collapsing in on itself. And due to the gravity collapsing in itself, nothing can escape it, not even light.
Yeah, light gets taken away.
That's why we can never really find it. That's why they're sometimes hard to find, but sometimes easy to detect. Since when you look out in the night, when they go looking for it, there'll be this blackness where there should be light, and that's when they know there should be a black hole there.
Okay. Now, Valentine, do you have any understanding of what the wormholes are? Did Rich do a good job on explaining what the wormhole is and what it does?
It's... I feel like I'm the student in this because...
I thought that was a black hole in that situation.
No, he explained both. He explained both. He explained the black hole and he explained the wormhole. I'm going back to the wormhole explanation.
Okay.
I'm just saying I feel like I'm a student in this because I know nothing about wormholes and black holes. So anybody who's viewing this right now or like watching, I'm with you. I don't really get it, but from what I know, what Rich said, the definition is from like basically in space from point A to point B. And it's like this hole that you can like travel through and get to. It's like a shortcut, I guess. And then a black hole is something where like light doesn't even survive in. Like the other side of a black hole is a mystery, I guess. Right?
Yeah.
We don't know. There's a lot of theories about black holes and what is in them, or can we even get in them? Are they really a dimensional to a portal to another dimension? What are they exactly? We don't know. We just know that gravity is really strong, and there's theorized that if you get yourself close enough to the event horizon, that is between where the black hole starts, there's something that they call spaghettification, where you pretty much go spaghetti and you'll die because you're not moving at a fast enough rate for you to be able to survive. And along with the other theories that are out there with black holes, is they slow down time as you get closer. As you get closer to the to the black hole, the dark hole, time for you slows down. In other words, you are living years, but it's only moments for you because your clock slows down. And all of this stems from Einstein's theory of relativity. Both the wormhole and the black hole both stems from this theory. Does Valentine or Salt have a question about the theory of relativity?
No, not particularly. Science, or not, I won't necessarily say science, but more of just things like that. It was just kind of went over my head. I mean, like it's, I don't know. When there's not a lot of
Um,
information or sort of say actual proof of things, it's kind of hard for me to wrap my mind around it, so to speak.
so basically, you're saying that time slows down, so it's like it's put on slow mo, and then you get basically processed like pasta through the actual black hole because you can't keep up with the time.
Yes, no. Maybe I need to do a little better
Okay.
job explaining. Maybe Rich can help back me up with the explanation of the black hole and what happens. So as you progress to the black hole, there is a force of gravity. Gravity becomes stronger. And so with Einstein's theory of relativity, it pretty much states in there, the short version and easy to understand. We'll have a link to all our things and definitions to work that we're talking about in the description below. Theory of relativity works in the black hole is due to gravity. The higher gravity there is, time works. And are you familiar with or have you watched the movie Interstellar? I'm going to use this as a way to help back as my backdrop as I'm
Nope,
explaining what's going on. No.
I have
I
not.
have not.
Okay.
I know
So
it was Christopher Nolan, right?
it was a Christopher Nolan film, you are correct, with Matthew
Right.
McConaughey and Anne Hathaway in it, along with Michael
Okay.
Caine and a few other stars that I don't remember right offhand. And
Probably should have watched that before this video.
in the movie, they have a planet that is near a black hole, near the event horizon, called Gangartua. And they have a signal, so they send out these astronauts to go and see if there's any planets available in this other universe, or this other, not universe, other galaxy, where humans can go and live on. Okay? And they got all these signals saying yes, all these signals saying no. So they arrive there and they look at the planets, and one of them has water on it. And they're like, well, this astronaut, her signal is still saying yes, it's positive, let's go down and visit. They go down and visit only to find out that she's dead.
Oh,
But she's only been dead. She only died relatively 20 seconds, 2 minutes before they arrived there. Or something along that
Hmm.
line, due to the way
oh.
gravity and the black hole in the center was affecting that planet.
So the way the event horizon was affecting that planet, it was years for everybody else, but only just mere minutes for her. So everyone there thought that
Wow.
she has been there for years and had things set up. No, she was only there for a few moments before. And then in the movie, they get stuck on there for about an hour or so before they get back. And when that happens, they did the math. It equates to, I don't remember exactly right offhand, but there's a 7 years for the amount of time that they ended up for a minute or something like that was 7 years. So they didn't want to be there for more than an hour or two because that was a lot of time and resources that they were wasting, and they wanted to get down and get it quick. And so when they got back,
Yeah.
um, Matthew McConaughey's daughter and children have grown up. They're now in their adulthood. Then they go and do other things. And then they decide to ride the event horizon so that they can launch Anne Hathaway to the last planet in the film that they're saying this is where we probably got to be at to live and make all this to work. When that happens, they're in there only for a few moments, but once again, another 20, 50 years jump happens because when Matthew McConaughey is found at the end of the film, his daughter is 80, 90 or so years old and is ready to die.
Wow.
So that event horizon, the closer you get, your clock slows down.
Mm.
But it's still the same from the distance point, and that's where the relativity comes in at with Einstein's theory with black holes. And there's even a time lag with our satellites in space orbiting us to where we're at on the ground. It's minuscule, like milliseconds or so difference, but it's causing a time difference because of the difference of gravity between where we're at and where the satellites are at. So that creates that's what's used with the theory of relativity. Another example is the airplane or the train and the clock. I'm not for sure if you're familiar with that.
No,
A
you should
little bit.
probably say it.
Rich may need to help me out because I feel like I'm about ready to mess this explanation of the of it. Um, just because with the clock, you're going at a fast enough speed that the clock stays still.
That does sound familiar. Because I know I believe the closer you do push the light speed, the more time sort of, I don't know if it speeds up or slows down.
Slows down, but you're still going the same thing because the clock is 12, and then you move your way outside of the clock. It's still 12, but because of the speed that you're traveling, it looks like it's 12, but it could be 2 or 3 minutes. But to you, it's still only 12.
That's what it was. Like, I never like when you get closer and closer to light speed, the more and more time changes.
And
And
what was
that
this?
there's
The turning the clock?
Mm-hmm. This deals with the
Huh.
clock and how it affects you as you're traveling.
This is all very crazy to me. That time can even be manipulated with and stuff. Like that seems so far-fetched.
well, to think about it, if a human would reach light speed, the body would actually start to expand, it would actually start to stretch due to the force that's being applied to it.
Wait,
That's
so our bodies would stretch?
yes. When driving, our body does stretch to a certain degree, but it's so small we don't realize it. But the faster and faster you go, the more you stretch due to the G forces being applied to your body. That's why the when faster you get, that stuff happens. That's why airplane pilots in the Air Force has to be able to stay conscious during that due to the pressure the body's being put.
Yeah, which is why they put you, especially when you're in the Air Force and whatnot, you have to go through some G-force training and shit, I believe, to see if you can even handle it.
Yes, I know when I was thinking about becoming an astronaut, I know one of my childhood dream was let me become an astronaut. Glorious dream. I know they would be put into this item where that would spin them around in a circle to imitate what it would feel like being launched into space. And I think they mentioned that we reach Mach 23 to break into outer space. I want to say that was the number. It's Mach
So if
23.
you didn't make Mach 23, you would just like
You
explode or something?
no, you couldn't break out of the atmosphere.
That's
So
when
you would crash into the atmosphere.
you want it,
Yeah.
you would crash back on the Earth is what would end up happening, which is why when you see the space shuttles, they have those huge boosters, and they use a lot of hydrogen, if I remember correctly, in the fuel to launch you up, to launch the shuttle up into space.
Hmm. So
There's a
you would just
lot of.
crash into Earth.
You wouldn't be able to break out, thus, in general, you would end up stalling, and then you'll start crashing, and you gotta be able to break the stall before you crash back into Earth.
Oh. This is stuff I've never thought of before. Like
That's
ever.
science
Now,
and
Right?
physics and
Science!
everything else.
now it's interesting. So we call it a black hole, and wormholes were also called at a time a white hole. So they believe that black holes pull you in, while the white hole for a time believed it would pull you out, and it would act as the opposite of the black hole versus pulling things in, be pushing things out. And some theories of the wormholes state that, yeah, as Rich explained, travel the fastest point between two things where space and time is folded. Another thing that people speculate, and this may not be possible because it will create all sorts of paradoxes if we're ever able to travel through a wormhole, but the wormhole basically, what they're saying in one theory is you will travel in not just space but also time, where you probably will be able to travel forward in time or travel backward in time. Now, if I remember correctly, the movie, one of the Planet of the Apes movies, did something similar to that, where the pilot went after his ape and he was sucked into all these wormholes after the other, and he ended up on the Planet of the Apes, where the humans were second-class citizens and the apes were like humans, and they had their own class system, and the humans were slaves.
I remember that. I also remember a Star Trek Voyager episode where they encounter a wormhole, and they go talking back and forth with the fleet on the other side, and they sent message to be delivered to Earth. I don't remember the name of the person who was like Spock on that said fleet. Message
Tuvok.
goes, yes, mention how he didn't bring this up, so the rest of the crew had the hopes up, but that spaceship never reached Earth due to him finding out which spaceship it was, and it found out that was giving message to someone who was in the past. So that possibility has been thrown around. But another interesting thing, if I remember correctly, is that they also believe that wormholes are actually very macroscopic. They're nothing big enough for us to travel through.
The article I was reading talked about how the wormhole is 10 to negative 33 centimeters. So you have the centimeter, and you move the decimal place in front of that 10 33 times.
Jesus.
That's how small it is.
Wow.
That's ridiculous.
So you wouldn't be able to fit.
'Fit. Yeah, we wouldn't be able to fit into it. 'Cause it would be 10 to the negative 33 centimeters. So you have the centimeter, and you move the decimal place in front of that 10 33 times. That's how small it is. That's ridiculous.
That's
because it's that microscopic. It's that hard to detect, such as with the thing with black holes or dark holes, they're that hard to detect. And then rises, and then this is where the science fiction comes in and where the science comes in as well. If we're able to enlarge the wormholes, would we be able to survive in it? Now remember the discussion that we had with Val last week. Right now with our current tech, we can't survive in space.
Right.
Do you think with what our astronaut friend or your astronaut client was saying, would you think it's even possible for us to be able to travel through a wormhole if right now we can't survive the radiation of space for an extended period of time?
I'd have to say no. Probably not. Who knows what's in that little like pin size? Like, first
Or
of all, I
smaller.
don't even know. Yeah, I don't even know how you would like fit in there. And if there was
Or
like a crazy warped way of like, like condensing the molecules down to like that small and fitting through it, how would you get reassembled again? Like, I don't see it as feasible.
Well,
that's
that also
breaking the laws
comes
of
down
physics.
to the thing of wormhole. It's just this, in a sense, hole in space where it just goes straight through, like a tunnel, we'll say, a very short tunnel that you travel through from one side to the other, but it'd be more instantaneous.
Yeah, but how would you how would your molecules reassemble again?
With it being instantaneous, you wouldn't be reassembled, disassembled. It's just this. You shouldn't realize that you passed through it. You're like making assumptions that those things will happen, but we really don't know that it would. Because it's a hole. You got a wormhole because you go in one and out the other different location. But with it just being more like this dot due to people believing space being pulled in and all that stuff, is this hole that was formed that you just travel through and then you are halfway across the universe, to the galaxy. That's how they view it.
It sounds like Battlestar Galactica, the newer series, took that same idea with some of their starships where they were able to jump instantaneous from one location to another location in space.
That could be a very similar concept.
Because the way you're describing it, you go into the wormhole at one end and then next thing you know you're on the other end and you're not in this warp space or hyperspace like they show in Star Trek or in Star Wars.
Agreed.
So it sounded like you had something you were going to say.
It's, honestly, no. I don't even know what to say. In all honesty, that's just yeah.
And going back
Yeah,
to
I wouldn't even.
yeah, you don't know where or what.
No, not really. It's just kind of there.
Have we ever sent anything into a wormhole?
As I was saying, and as Rich was saying, it's so microscopic, it's not possible.
Or a black hole? Either one of those?
The black holes, it's sending something. It will take a while for anything to reach the closest black hole. I should have done more research about what the closest black hole is, but it will take years, probably centuries, before anything would reach the black hole.
It's the same thing with us. If we were to launch right now into space to travel to Andromeda, it would take years to make it to Andromeda.
I'll take light years.
Yeah, it's light years, so it's years, it's centuries, it's millennia.
Past
not-
your
Wow.
lifetime. Our
Well,
lifetime,
yeah.
let's put it that way. Our
you would have
lifetime,
to.
not
To
yours,
several
ours.
fleet of people knowing that moment they leave, they'll never come back, and neither would any of the generations. Remember, by that point, none of the spaceship won't break down in the meantime trying to get to said location.
And then food and things like that to even survive on.
We're just not there yet. Like, the way that we would have the technology to travel light years would have to come from an element or something that we haven't discovered yet. And until that happens, like, it's always going to be an impossibility.
Because one light year, to put this in perspective, is 1.8 times 10 to the 12th power miles.
Yeah, I'm not doing the
So,
math
like,
on that.
yeah, that's like, I mean, that's complicated enough that I'm like, whoa, you know?
So that'd be, for those who are listening that doesn't do that, that's in the metrics, who's using the metric system instead, that's 9.6 times 10 to the 12th kilometers. So it's a very long distance.
Long distance and you're
We would
traveling
have
at
to,
that
like,
ridiculously fast speed, you'd be knocked unconscious.
Yeah. That's
I
why
mean,
Hooray!
that's
it'd
why
have to be
one
like warp
traveling at
drive
light speed.
status.
That's what traveling at light speed will probably kill you. If you were traveling at light speed and could stay awake and focused, you gotta have enough supplies to last you a year just to get to that one location. Thus, if we want to have fun and calculate, Andromeda is the closest
He's actually gonna
galaxy.
do the math. Oh god.
Yeah, what do you expect? I mean, it's all important.
Um,
It's important to know the distance and that you're traveling, so that way you can safely, well, that way you can prepare yourself the best way possible for you to go there.
It's being about 2 million light years away.
God.
So that's 2 millennia.
Can I get store credit for that?
Yeah, you can get store credit. We'll make sure we pay you several lifetimes worth of supplies. Do you want that in beef? Do you want the meat?
So that'd be 91.
See what you did there, sir.
That I don't know the exact number because I'm not using my scientific location because I don't have a scientific calculator next to me. But that would be about 91 something times 10 to the. I don't have the scientific.
Oh my gosh.
It's a lot of
It's a
miles.
lot.
Just a little bit.
That's why using the term light years to represent that many, due to it would be easy to comprehend. Because from Earth to the Sun, it takes 8 minutes from the light from the Sun to reach Earth.
So if the sun was to expand, we wouldn't realize that the sun expanded until 8 minutes later.
Wow.
Well, we're dead.
So when the sun sets, the sun's already been set, so to speak, for 8 minutes. We're just now realizing that it's finally setted. And that is once again going back to Einstein's theory of relativity, because of the distance and in time and the traveling that it takes. And then going back to the wormhole, assuming we have the technology to expand it and to be able to maintain it and let it be stable, we would have to find some sort of exotic type material for us to survive, because we don't even know what's in the wormholes themselves or what all type of elements there are in there.
Because it's really a mystery. It's something that somebody thought up of, and it's a plausibility. Because you look at space, space is like a fourth dimension.
Well, time is a fourth dimension.
unless traveling space, due to all the factors and gravity and everything affecting you, it could also affect time.
And that goes back to Einstein's theory of relativity. If you travel 10 years in space, do you age 10 years? Or do you look the same? Due to the lack of gravity. This is a thought exercise, and we want to hear your thoughts on all of this and help correct us on our mistakes or the miscalculations that we may have, so we're accurate in what we're talking about. Do the two of you have questions, or your mind still spinning around of what we've been talking about?
I guess you can say it just kind of just sucked into itself and just gone. Yes, I'm aware I made that comment just because of this topic.
Well, like the only reason
I
the only reason why I took the time to understand this is because I'm a kid, I wanted to be an astronaut. Thus, I studied a lot about black holes and wormholes, and just space in general. Because we've talked about black holes, we haven't talked about supernovas, which is another form of black holes, which can be a topic for another day or another time. Because in general, our entire galaxy is spinning around a supernova, which is a very powerful black hole.
Well,
now that came to be, I do not know.
If I remember correctly, you have a black hole, then you have the supernova. Black holes is when it collapses. Supernova is when it expands. So you have two different effects that happen. You have the expansion, then you have the collapse. Once again, if something was happening to the Earth, whether it was to collapse or to expand, it would take 8 minutes before we were to notice it. Or at least see the effects. We may have noticed it more immediately
due to the
heat, but we wouldn't see it until 8 minutes later.
And another thing, after this is going more science-based, this sun will expand and then it'll turn into a white dwarf, which is smaller but produces a lot more heat. So, but the only way black holes come, I think, is off from red giants. If I'm getting my thoughts correct. Our sun isn't that big enough to turn into a black hole. It's the very big stars that are massive. Due to the sheer size and mass, once it starts expanding, that's when gravity collapses on itself. So not every star turns into a black hole.
We'll find a video that will show, and we'll post it in the description, all the various sizes of the stars and where our star compares to other stars. There's one that is so massive that ours is just a tiny dot on it. You can barely see it, the shape compared to it. Because it's that big.
Oh yeah, it's ridiculous.
So, Belle, Salt, do you have any other, or do you have questions? Because you feel like your mind is just being blown away.
That's gonna be one of those ones I'm gonna have to just take each one and just do like a slow, in-depth. Oh hey, and just kind of do that. There's some things I don't take information in a lot. depending on what it is. Especially if it's a lot of information, I don't take it in very well. That's one of those ones I'll have to do, a bigger, in-depth looking across multiple things, and like, oh, okay, I understand this now. Or better, I should say.
Maybe a topic we may want to come back to and touch again in, in a few weeks.
Yeah, I think so.
Revisit it,
okay.
and then probably go back and wait. Lost my train of thought.
Well, okay, so I'm just gonna admit something about myself right now, and I'm just gonna go there. I am not the most like mathematical, sciencey person, and I failed geometry 3 times in high school because I just don't get math. Like I don't get it, and I don't get like science and theories and anything either. So this whole podcast was like one of those hard classes I had to take in college where I was just like barely like clawing my way through it because I didn't understand. So hopefully next time I'll just do some research, like figure out a little bit more, because I feel like I've been very silent, but I've been very silent because if you knew me in college in one of those classes, I was just like, because I didn't know what to say.
Yeah. And I'm kind of one of those persons, if I'm not entirely sure with my answer or just anything in general, I typically don't speak up.
Agreed.
But that's just me. That's why I was a lot more silent on this one, just because I'm like, I'm not confident in my words, so I'm not going to say a whole lot.
Okay, question then for the two of you.
Possible answer.
Would you, in a few weeks, be willing to come back and discuss this again after you've done research? And look more into it?
Well,
and then discuss this
probably
again?
where I'm a little more better understanding of it, let's put it that way.
Yes, that's why I use the term
Some things
research.
takes me longer to understand. Well, even doing research, understanding it's a whole another situation because space and things like that is not my forte. So it takes me a little longer to pick up and or understand it than what I would normally.
Right, and I'm fully warning you guys, I still may not get it. Like, I could read a million things about it, and if it's something I just don't understand, I'm just probably not going to understand it. But I will do my best to be a part of the podcast.
Well, if anything, you can be the one to come up with questions and ask questions.
Yeah. I could do that.
Or you may not feel like you'll be understanding on what you're reading, or what you read, you can ask questions, and we can go from there. And I feel like this is a good place to stop. And if you guys in the comment section want more information or want us to answer more questions, we'll be willing to go in and answer the questions in the comment sections about wormholes in space and other things. So this has been a SaltyChillersEntertainment podcast. This is Hero Darkness.
Don't watch it.
Which numbers?
Valentine.
And as always, guys, stay salty.
God, you're the ones that we shelter.